In this video, I'll be working through the question you see on the screen here from the Maths Paper 1-3 from 2024 Cambridge A-Level exams. If you're looking for a different question from this paper, have a look in the description below. There should be a link to a playlist. And if you're looking for a different paper entirely, have a search on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to doing in the classroom. But remember, we're not in the classroom, we're on YouTube, so take advantage of that. Pause, rewind, even watch it at a different speed. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, a share, or even a super thanks.
In question 10, they're talking about geometric progression. And I don't know if my English is bad or their English is bad here, but they say has first term 2. I'm guessing that means the first term is 2. It's not very clear to me, but we'll assume, and from the answer to in the marking scheme, I will assume the first term of this geometric progression is 2, and they call that A1 as well. And we have A2 and A3, and they tell us the common ratio is OR, which is what we'd expect. The next bit of information they give is again a bit cryptic. They tell us this equation works, and 9 over 2 A5, that's the fifth term, A4 and A5. 9 over 2 multiplied by whatever this term is, added to 7 times A3, whatever this term is equal to 8. Now, given the fact that they told us the first term is 2, this is enough information to get everything. Usually we need basically 2 bits of information, A and OR, most simply. So this should be enough information to get everything. They've asked us to find OR. Okay, geometric progression, let's use the formula. Usually it's UN. I'll use AN in this case because they've given us A's. AN is equal, I better just double check I'm using the right formula. Yeah, A multiplied by OR to the power of n minus 1. That gets any term. The first term, well, the first term's easy because it's n minus 1. 1 minus 1 is 0, so the OR's, so A is equal to A. The second, the third, the fourth, any of them. This question, we're interested in the fifth and the third term, so let's find them. A3 is equal to the first term, which is 2, times OR, times to the power of 3 minus 1, and that's 2. So the third term is 2 times OR squared. The fifth term, very similar, is 2 times OR to the power of 4. We can use this bit of information, put it into this equation, and we'll only have one unknown. There'll be an OR here, there'll be an OR here, and that'll be the only unknown we have. So let's see what it looks like. We get 9 over 2 times A5, that's 2 times OR to the 4, plus 7 times 2 times OR to the OR squared equals 8. If we clean this up a bit, we have 9 OR to the 4 times 14 OR squared equals 8. This is a quadratic. It's just OR squared squared. OR squared and no OR squareds. If we write that out a bit more commonly, we get 9 OR to the 4 plus 14 OR squared minus 8 equals 0. So you have to be okay solving quadratics that are a little weird like this one. You can use the minus b formula, or again your calculator will probably do this, but 2 things that multiply to get OR squared. OR 4 is OR squared and OR squared. 2 numbers that multiply to get 9, 2 other numbers multiply to get 8, and they all combine to 14. You'll have to play around with it a little. Let me just remind myself. It's 9 and 1, and then it would be 2 and 4. So 2 times 9 is 18, 4 times 1 is 4, 18 and 4 can combine to get 14. If this 18 is positive, we need it there, and this 4 is negative, it'll work. So we're left with OR squared is equal 4 over 9, or OR squared is equal minus 4. Now you can abandon this one because we're in paper 1. Paper 1 doesn't have any complex numbers. So that one's gone. You can't have r squared being a negative. Impossible. So we solve this, we get r is equal to plus or minus the square root of 4 is 2, square root of 9 is 3. 2 answers. They only wanted one answer, so let's be careful. You're going to lose a mark for this. They tell you r is bigger than 0. They write that in the question. So that means r must equal 2 over 3. And that's the answer to part A. Part B is kept quite simple. They just ask you to find the sum of the first 20 terms. Should be quite straightforward. We know everything now. We know A and we know R. So the sum of the first any terms is gotten by the formula. Sn is equal, I better remind myself here, Sn is equal to A multiplied by 1 minus R to the power of n divided by 1 minus R. So we can find any number of terms we want. In this case we want 20. So we write this again. S20 is equal, we know A is 2. 1 minus, we know R is 2 over 3 to the power of 20 divided by 1 minus 2 over 3. You put all that in a calculator now if you want. Let's make it a little neater ourselves though. Top row will become 2 minus 2 times 2 over 3. See, you need a calculator for this bit, so bottom row becomes 1 over 3. That's like multiplying the top by 3. So that's becomes 6 minus 6, 2 to the power of 3, to the power of 20. You need to put that in the calculator at some stage. And that'll come out to 5.998 to 4 significant figures. Now, I was going to talk a little about this until I see in part C. I don't need to talk about this because I'll talk about it in part C. And I don't need to clean the board either. Let's just squeeze it in a box here. Because part C, even though you get 3 marks, it's one of the easiest 3 marks I've ever seen.
Or is it? I just noticed a massive mistake while editing this. They didn't ask for the sum to infinity of the original sequence. They asked for it as a new sequence, A2, A5 and A8. So to answer that, let's write that down as 2r to the power of 4 and 2r to the power of 7. That means the new A, the new first term of the sequence, is actually 2 times 2 over 3, which is 4 over 3. And the OR of this new function is the second term divided by the first term, which will just give us the common ratio of OR cubed. And remembering OR is 2 over 3, so 2 over 3 cubed is 8 over 27. The sum to infinity is the first term divided by 1 minus the common ratio. In this case, that's 4 over 3 divided by 1 minus 8 over 27, which cancels down to be 36 over 19. This is a lesson that I should read the question carefully before answering it.
Okay, if you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.